Silence swallows your suit alarm mid-warning. Your heart stops on the Martian surface. Cold claims the last warmth in your skin within seconds. Surface pressure here sits near 600 pascals. That is a tiny fraction of Earth's air. Exposed liquid boils away into vapor almost instantly. Average temperature hovers near 63 below zero. Carbon dioxide fills 95% of this thin air. Radiation floods the ground because Mars lost its magnetic shield. If a person dies on Mars and their body's never recovered, the cold, oxygen-starved, radiation-soaked surface will not let them decay. It will turn them into a natural mummy that could last, largely unchanged, for thousands of years. Iron oxide paints the entire landscape a deep rust red. That same chemical reaction will eventually reach your exposed skin. Millions of years of that slow burn color the whole planet this way. Your body becomes a monument the moment breathing ends. That fate defies everything Earth ever taught you about death. Noon at the equator can climb near 20 degrees. Polar nights crash past 96 below instead. One planet swings between both extremes within hours. Wind carries fine red dust across your frozen skin. Nothing on this surface behaves the way your body expects. Earth trained your instincts on a wetter world entirely. Bodies left exposed in a field draw flies within hours. Bacteria multiply through warm tissue by the next day. Scavengers arrive quickly. Insects lay eggs, and bone shows through skin within months. Every stage runs on a script written by Earth's climate. That script needs oxygen and warmth and moisture together. Mars deletes all three at once. Nothing, no fuel remains. Decomposition simply cannot start. Aerobic bacteria drive most of that earthly rot. They breathe oxygen the same way your lungs once did. Mars offers almost none, just 0.16%. Those bacteria stall before they multiply at all. Trillions of organisms inside you find themselves stranded without air. Anaerobic microbes try to fill the gap. They work briefly without any oxygen. Cold beats them within hours. Ice locks your cells before they can act. Moisture leaves your body first, and leaves fast. Near vacuum pressure pulls water straight from liquid into gas. Your eyes cloud as fluid sublimates into the thin air. Sweat and blood and saliva vanish through that same process. Skin tightens as its water content escapes outward. Lips pull back from teeth as tissue dries and hardens. This mirrors freeze-drying more than any dramatic film scene. Within days, your softest tissues surrender every drop of moisture. Leather, that is what remains. Flesh stays stretched permanently now. Hollywood often shows bodies exploding the instant they hit vacuum. Real physiology works far slower and far quieter than that. Skin and connective tissue hold pressure well enough to prevent any rupture. Gas trapped in the lungs and gut may expand and vent gradually instead. No dramatic burst occurs, only a slow, silent exhale into the thin air. Cold seizes whatever the vacuum leaves behind. Enzymes inside your cells once triggered autolysis after death. That chemistry depends entirely on warmth to keep moving. Martian night drags your core temperature past freezing within hours. Frozen enzymes stop cutting through cell walls at that point. Ice crystals form inside remaining cells and lock every structure. Your tissue holds its shape because the chemistry has gone still. Putrefaction needs that same warmth and oxygen supply. Bacteria responsible for bloating and blackening flesh need both. Neither exists here at levels those microbes require. Your body skips the bloated, blackened stage entirely. A body found centuries later would still resemble the moment it fell. Frozen, locked, unchanged. That is the state your body settles into within one Martian night. Time works differently on the world without rivers or forests or decay cycles. A single Martian year lasts nearly twice as long as one on Earth.
Even so, that longer year barely registers against a timescale measured in millennia. Your body would outlast thousands of those extended Martian years without changing shape. Radiation finishes what cold and vacuum started together. Mars lacks a magnetic field able to deflect incoming particles. Cosmic rays and solar radiation bombard the surface directly. Surviving microbes absorb lethal doses across months and years. Sterilization spreads through your remains slowly, cell by cell. Whatever biology survived the freeze eventually falls completely silent. Your body crosses from a frozen corpse toward fossilized tissue. Ultraviolet light reaches the surface far stronger than on Earth. No thick ozone layer exists here to filter those harsher wavelengths. Skin exposed to that light bleaches and hardens within weeks. Pigment breaks down first, then deeper protein structures follow. By the time radiation sterilizes remaining microbes, sunlight has already reshaped the tissue.
Beef jerky curing inside a dehydrator follows this exact same chemistry. Heat pulls moisture out, while salt blocks bacterial growth. The result sits on a shelf for years without spoiling. Camping food follows that same principle inside a freeze dryer. Water leaves under low pressure until only dense tissue remains. Your body undergoes that identical chemistry at planetary scale. Near vacuum pressure replaces the dehydrator's sealed chamber. Deep freeze temperatures replace the humble kitchen fridge. Empty skies replace the sealed bag. No oxygen remains anywhere to feed a single bacterium. Egyptian embalmers once used dry desert sand to draw water from bodies. Andean ice mummies formed the same way inside frozen mountain peaks. Both methods rely on cold and dryness and low oxygen working together. Mars simply performs that same trick at a scale no desert or mountain can match. A 5,000-year-old body found in the Alps still had skin, hair, and tattoos intact. Multiply that preservation window by 1,000 and you approach Martian timescales. The Moon offers a useful comparison since it lacks any atmosphere whatsoever. Apollo-era equipment left on its surface still looks essentially unchanged after decades. No wind, no rain, and no bacteria have touched that hardware even once. Mars adds cold and a faint atmosphere to that same airless preservation principle. Together, those forces make the Martian surface an even more effective vault than the Moon. Bone survives longer than any soft tissue around it. Calcium and phosphate crystals resist sublimation far better than skin or muscle. Marrow inside those bones dries out slowly across the following weeks. A skeleton wrapped in leathery skin becomes the final, stable form your body reaches. That form then persists essentially unchanged for the rest of geological time. Earth finishes its decomposition story within a single decade. Flesh returns to soil, and the story ends there for good. Martian refuses to write that same ending on any familiar timeline. Your mummified form could stay recognizable far longer than humanity has existed. You freeze mid-sentence inside a story that never turns its final page. Martian gravity pulls at roughly 3/8 the strength you knew on Earth. A falling body settles more slowly here than it ever would back home. Limbs come to rest at an angle gravity alone would never produce on Earth. That final posture becomes part of the permanent record etched into the landscape. Dust devils occasionally spiral across the Martian plains in tall, spinning columns. One passing near your resting place could scatter a thin layer of sand. That same dust could just as easily settle back and reseal the scene. Either way, the underlying tissue beneath stays locked in its frozen state. Your face keeps its exact shape. Skin drawn tight over bone holds your final posture. Dust settles across you gradually, one grain at a time. Wind moves that dust in slow drifts, but rarely disturbs you. Sand occasionally buries a shoulder, then uncovers it decades later. You become a fixed point on a world without active weather. Scale hides inside that single fact. A human lifetime stretches roughly 80 years.
Your body could remain intact for thousands of lifetimes stacked together. Empires will rise and vanish long before your form changes at all. The gap between your death and your disappearance dwarfs recorded history itself. Engineers studying exact this combination gain something valuable from your fate. Suit designers learn how fast moisture escapes exposed human skin. Mission planners use that data to build stronger emergency protocols. Every case like yours becomes a lesson etched into future hardware. You quietly rewrites checklists inside control rooms you will never see. Scientists on Earth already model these exact conditions inside vacuum chambers today. Test tissue gets frozen and irradiated and depressurized under controlled laboratory settings. Results consistently confirm what Martian conditions would do to human remains directly. Moisture vanishes first. Cellular activity halts second. Radiation damage accumulates last, exactly as it would on the real surface. A rescue team arriving months later would witness something unexpected. Still air surrounds the site, carrying only fine dust and silence. A dry, preserved figure rests against the rust-colored horizon exactly as it fell. The scene looks frozen in a single captured moment, untouched by any process. Permanent settlements will eventually face a question no brochure ever mentions. Colonists arriving in coming decades will need protocols for handling remains. Retrieval missions may someday find bodies like yours still intact. Your preserved form becomes a data point explorers never expected to need. NASA's Perseverance rover already carries instruments built to detect organic molecules. Those same instruments could, in principle, identify preserved human tissue from orbiting data. Future missions may carry far more sensitive versions of that same technology. Finding a body this way would confirm everything laboratory models already predict. Robotic missions already practice locating and identifying objects across this same terrain. Those same navigation and imaging systems could one day locate a fallen colonist. Recovery would require careful handling since sudden warmth could trigger decay. Bringing a body back to Earth could undo thousands of years of preservation within hours. Deeper questions surface once scientists study bodies preserved this way. Mars may already hold ancient organic material locked in that same state. Microbial life could sit frozen right now if it ever existed here. Every answer this planet gives about preservation raises a newer question. The next frontier for human exploration runs through this uncomfortable fact. Habitat engineers must now plan for permanence, not just survival. A colony built to last decades must plan for remains lasting millennia. That single requirement never existed before this planet forced the issue. Mars carries the name of a god built for war and destruction. That same battlefield world turns out gentler to the dead than the living. No tomb built on Earth matches the stillness this planet offers. Cold and vacuum and radiation strip away every process that erases a person. Then the planet simply steps back and waits. Your body becomes the exhibit inside a museum with no visitors and no lights. There is no closing date on this tour. Mars keeps its secrets the same way it keeps its dead, patiently and for longer than anyone alive could ever imagine.